In this video, we are going to get really good at figuring out the oxidation numbers for elements in a chemical compound because we are going to do a ton of examples. We're going to start out with some examples that are pretty basic and straightforward, and then we will go step by step into problems that are a little bit more challenging. Okay, so these are the rules that we'll use to figure out oxidation number, and I got a periodic table here to help us out. Our first example is CaO. Let's take a look at the individual elements. So Ca, calcium, is here on the periodic table. It's in group 2A, and we have a rule for group 2A. Elements in group 2A are always plus 2. So that's calcium's oxidation number. Now we have O, oxygen. There's a rule for oxygen. It usually has an oxidation number of -2. It's -1 in peroxide. Definitely not in peroxide here. So its oxidation number is -2 for oxygen. Now check this out. There's a third rule, and that's this one right here, that the sum of oxidation numbers for a neutral compound should equal 0. CaO here is definitely a neutral compound. There's not a charge after it. And you'll see that if we add these oxidation numbers together, +2 -2, we get 0. So the oxidation numbers sum to 0 for this neutral compound. CuI. So there's not a rule for Cu, which means that we're going to have to figure out its oxidation number by using what we do know. And that's going to be what we know about iodine here, I. I is a halogen. It's in this group here, 7A, and there's a rule for the halogens. The halogens usually have an oxidation number of -1, though they're positive with oxygen. We definitely aren't with oxygen here, so the oxidation number is going to be -1. To figure out the oxidation number of Cu, we're going to use this rule, that the sum of oxidation numbers for a neutral compound should equal 0. This is definitely a neutral compound, so whatever the oxidation number on Cu is, when added with -1, should give us 0. And that is going to be +1. -1 is 0, so the oxidation number on Cu is +1. FeBr3. So there's not a rule here for Fe, which means that we've got to figure out its oxidation number using what we do know. We'll focus in here on Br. Br is one of the halogens in group 7A. There's a rule for this, that the halogens are usually -1, except with oxygen. Now here we have 3 Brs, which means that we have to multiply this oxidation number times 3 to account for these 3 atoms here, which means that our total number for Br is going to be -3. Now, to figure out the oxidation number of Fe, we'll use this rule that the sum of oxidation numbers for a neutral compound should be 0. That means that the oxidation number on Fe on iron should be +3, because we've got +3 -3 equals 0. So the oxidation number for Fe, +3, oxidation number for Br, -1. NH4Cl. We don't have a specific rule for nitrogen, N here, but we do know stuff about hydrogen and chlorine. Hydrogen is +1 with nonmetals, and it's -1 with metals. It's combined here with nitrogen and chlorine, which are both nonmetals, so its oxidation number in this situation is going to be +1. Cl, chlorine over here, is one of the halogens, usually -1, positive with oxygen. It's not with oxygen, so it's safe to call its oxidation number -1. Now we got to do a little bit of multiplication. We got the +1 oxidation number on hydrogen, but we have 4 of them. So we got to do +1 times 4, which is going to give us a total oxidation number of +4. Okay, now that -1 plus whatever nitrogen is should give us 0, because this is a neutral compound. So what is nitrogen's oxidation number going to be? It's going to be -3. -3 plus 4 minus 1 gives us 0. So that's how we figure out the oxidation number for nitrogen. CO3, 2-. This thing is a polyatomic ion that has a charge of 2-. We got to take this into account when we do the calculations later. So carbon, C, there's not a rule for that, but we do know some stuff about oxygen. Oxygen is usually -2, except in peroxides. So that's what I'll put as its oxidation number here. Now we have 3 oxygens in this compound. So I'll do -2 times 3, which gives us -6 here. Now, the oxidation number on carbon plus the oxidation number on oxygen should give us -2, which is the ion charge for this polyatomic ion. So, what then is going to be the charge on carbon here? It's going to be +4. +4 minus 6 equals -2 plus 4 on carbon. Ba2+. Ba2+ here is a monatomic ion. It's an ion that's made of only one atom, which means that its oxidation number is the same as its ion charge. So Ba2+ has an oxidation number of +2. H2, P2, O7, 2-. What do we know about the elements in this compound? Well, hydrogen here has an oxidation number of +1 with nonmetals and -1 with metals. Phosphorus and oxygen are nonmetals, so hydrogen is going to have an oxidation number of +1. Now phosphorus here. There's not a specific rule for phosphorus, so we'll have to figure out its oxidation number later using what we do know. Oxygen usually has an oxidation number of -2. Now let's do some multiplication. We have 2 hydrogens, so we're going to do +1 times 2 to give us a total number of +2 from the hydrogen. We have 7 oxygens, so we're going to do -2 times 7 to get -14 for the oxygen. Now, to figure out the oxidation number of phosphorus, we will add all of these together, and we should get 2-, -2, because that is the ion charge for this polyatomic ion. I'm getting that number from right here. So, what are we going to add together with these 2 numbers to get -2? It's going to be +10. I got +2 plus 10 gives us +12, -14 gives us -2. So, the total oxidation number for phosphorus is +10, but there are 2 phosphoruses. So I've got to take this +10 and divide it by 2, because this oxidation number of 10 is divided between the 2 different phosphorus atoms, which means that the oxidation number for each one is going to be +5. +1 plus 5 minus 2. O3. O3 here is what I'd call an element by itself. It's just oxygen. It's not combined with any other elements, which means that its oxidation number is going to be 0. KClO3. We'll start with K. K is potassium. It's right here on the periodic table. It's in this column, which is group 1A. Members of group 1A always have an oxidation number of +1. Now we've got Cl. Cl is one of the halogens here in group 7A. The halogens are usually -1, although they're positive with oxygen. Here, Cl is with oxygen. So we know it's going to have a positive oxidation number. We don't know exactly what it's going to be, so we'll have to figure it out using the other information. Now we'll move on to oxygen. Oxygen is usually -2, so I can write that in right here. Okay, now do a little multiplication. We have 3 oxygen atoms, so we're going to do -2 times 3 to give us -6. That's a total number for oxygen. We got +1 from the potassium, and this plus whatever Cl's oxidation number is should give us 0, because this is a neutral compound without a charge. So we're going to have +1 plus 5 to get +6 minus 6 equals 0. So the oxidation number for chlorine here will be +5. This is one of the unique examples where a halogen doesn't have an oxidation number of -1 because it's paired up with oxygen. Instead, its oxidation number is positive. H2O2. Okay, H, hydrogen, has an oxidation number of +1 with nonmetals. Oxygen is a nonmetal. Oxygen here is usually -2, but -1 in peroxide. Look at this. It's hydrogen peroxide, which means that its oxidation number is a rare -1 in this situation. Now just check this out for the multiplication really quickly. There are 2 oxygens, and each of them is -1, so we get a total of -2 here. There are 2 hydrogens. Each one of them is +2, so we get +2 for the hydrogen. +2 minus 2 equals 0. Just remember that oxygen is -1, not -2, when it's in peroxide. NaBH4. Okay, Na, sodium, right here in group 1A. Group 1A elements are always +1. B, boron, we don't have a rule for that, we'll figure it out. H here, hydrogen, +1 with nonmetals, -1 with metals. Sodium here is a metal, so that means that hydrogen is going to have an oxidation number of -1 because it's with a metal. Now we'll do the multiplication. -1 times 4 gives us -4. +1 from the sodium. What is boron's oxidation number going to be? Whatever it is, it's going to add with the other numbers to make 0 because this is a neutral compound without a charge. So boron's oxidation number is going to be +3. +1 plus 3 minus 4 equals 0, an oxidation number of +3 for boron here. Br(F)5. Bromine and fluorine are both halogens. The halogens usually have an oxidation number of -1, but both of these elements can have negative oxidation numbers because this is a neutral compound, and so the total oxidation numbers have to add up to 0. That's not going to happen if they're both negative. So how are we going to deal with this? Well, we'll focus in on this rule here, and that's that fluorine is always -1. Notice that for the halogens here, I said they are usually -1, but they don't always have to be -1. So fluorine here we know is always -1. -1 here, we have 5 fluorines, so we'll multiply this by 5 to get -5 total. Now, the oxidation number on Br has to be +5, because +5 minus 5 is going to give us 0, and this is a neutral compound. So that means that in this case, the oxidation number on Br is +5, so that it can balance out the -1 oxidation number on fluorine. This is one of the rare cases where 2 halogens bond together. Fluorine will always be negative. It will always have this oxidation number of -1, and the other halogen will end up having a positive oxidation number. Here's our last example. Ca, and then we have parentheses, ClO4(2). Okay, let's figure out these oxidation numbers. Ca, calcium, is in group 2A, so it's going to have an oxidation number of +2. Cl is a halogen. It's usually going to be -1, but it's going to be positive with oxygen. There's oxygen here, so we've got to figure out Cl's oxidation number later. Oxygen here is usually -2, so I'm going to write that in. Now it's time for some multiplication, but we've got to be particularly careful because there are these parentheses and the number outside the parentheses. The first thing let's do is do the multiplication within the parentheses. Okay, we have oxygen here with an oxidation number of -2, and we have 4 of them. So I will do -2 times 4 gives me -8 total. But now we have these parentheses, and we have this number 2 outside of the parentheses. That means that we have 2 of this whole thing. The math that I did here was only the oxidation numbers for one of these because there are 4 oxygens for each, but I have 2 of them. So I got to take this number here, -8, multiply that by 2 to get -16. All right, so I've got +2 from the calcium. I got -16 from the oxygen. That should add up with the oxidation number from chlorine to give me 0. So +14 is going to be the oxidation number on chlorine. +2 plus 14 minus 16 equals 0. But remember that we have 2 of these here because of this number outside the parentheses. So we've got to take this 14 and divide it by 2 to get an oxidation number of +7 for the chlorine. Remember, this is all because of these parentheses that mean we have 2 of this whole chunk. Okay, so +2 for calcium, +7 for chlorine, and -2 for oxygen. So, I bet you've gotten really comfortable with figuring out these oxidation numbers. After watching this video, I hope that you are all set.